to find a discovery of this nature, was certainly nothing that we expected.
There is a dry cave in the high desert of southern Oregon where the dirt has not been disturbed in 14,000 years. No wind reaches the back chambers. No rain seeps through the rock. Whatever falls to the floor there simply stays, layer after layer, undisturbed, waiting. In the early 2000s, a researcher named Dennis Jenkins knelt down in that stillness and pulled something out of the ground that had no right to exist under the story America had been telling itself for almost a century. It wasn't a spear point. It wasn't a skeleton. It was something far less glamorous and far more devastating to the textbooks. Preserved human waste, dried by the desert air, sealed in sediment since before the pyramids, before Stonehenge, before anyone on Earth had thought to write a word down. And when scientists finally cracked it open in the lab, what came out of it would help unravel one of the most stubbornly defended theories in American science. To understand why that discovery mattered so much, you have to go back to the story everyone was raised on. For most of the 20th century, American archaeology rested on a single, tidy narrative called Clovis first. The idea was simple enough to fit on an index card. Around 13,000 years ago, a small population of big game hunters walked out of Siberia, crossed a strip of exposed land where the Bering Strait now sits, and slipped south through a corridor that had just opened between two shrinking ice sheets. Once through, they spread across two empty continents full of mammoths, giant sloths, and land nobody had ever hunted before. Their calling card was a beautifully made spear point with a groove cut down each face, first identified near Clovis, New Mexico, in the 1930s. Wherever that point turned up, the story went you were looking at the first people ever to set foot in the Americas. It was a clean answer to a hard question, and clean answers are seductive. It got printed in textbooks. It got taught in universities. Careers got built defending it as settled fact. The trouble is, 13,000 years is a strangely short window to hold two entire continents' worth of human history. Put it in perspective. When Clovis hunters were supposedly taking their first steps onto this land, the pyramids of Giza were still 8,000 years in the future. Nobody anywhere on the planet had invented writing yet. And according to the official model, every single person who was ever in North or South America before that had to be squeezed into the few centuries after that one migration. It was a theory that left almost no room for error, and almost no room for anything unexpected, which made it exactly the kind of theory that a stray discovery could break. The first real crack came from an unlikely source, a groundhog. In 1955, an amateur historian named Albert Miller was walking his property near a sandstone overhang above a creek in western Pennsylvania, a spot people had been using as natural shelter for thousands of years. He noticed a groundhog had dug up loose soil near the rock face, and something in that soil caught his eye. He reached in and pulled out tools that looked far too old for where they were sitting. Rather than dig further himself, Miller quietly covered the spot back up and waited nearly 2 decades for a professional to take it seriously. That professional turned out to be archaeologist James Adavaggio, who began excavating the site, known as Meadowcroft Rock Shelter, in 1973. Working with painstaking care, cutting through the floor one thin layer at a time, Adavaggio's team eventually got radiocarbon dates back that placed human activity there as far back as 16,000 to 19,000 years ago. Thousands of years earlier than Clovis was supposed to have existed at all. He published the findings and stated plainly that the Clovis first model could not be correct. The backlash was immediate. Colleagues accused the samples of contamination by old coal deposits or groundwater carbon. Some simply refused to engage with the data. Adavaggio spent decades defending measurements he had taken with his own hands against critics who had never set foot in his excavation. But while that argument raged in Pennsylvania, a quieter and ultimately more damaging body of evidence was accumulating 2,000 miles away in the dust of Oregon. That's where Jenkins and his team come back in. The site is called the Paisley Caves, a set of dry rock shelters in the high desert of south-central Oregon, chosen almost by accident for how well the arid conditions preserve organic material. Beneath the surface, Jenkins found those fossilized human waste deposits, known scientifically as coprolites, and had them tested for ancient DNA. The results were unambiguous. The genetic material matched haplogroups A2 and B2, lineages directly tied to modern indigenous populations across the Americas. These weren't some mysterious dead-end population. They were ancestors of people alive today. Using accelerator mass spectrometry, a dating method that measures the organic material itself rather than surrounding rock or soil, researchers calculated an age of more than 14,000 years. That's roughly 1,000 years before Clovis technology is even supposed to appear in the archaeological record. One site, one method, and the Clovis first wall already had a serious crack running through it. A single date can always be argued away as contamination or error, no matter how carefully it was measured. What made the Oregon evidence so hard to dismiss is that it didn't stay isolated. About 70 miles from Paisley, near the small town of Riley in Harney County, archaeologist Patrick O'Grady began excavating a site called Rimrock Drawrock Shelter in 2011. Running through the sediment, there was a pale, unmistakable layer of volcanic ash, the fallout signature of a known eruption of Mount St. Helens, dated to roughly 15,400 to 15,600 years ago. That ash layer functioned like a geological timestamp. Everything above it was younger, everything below it was older. No argument necessary. Below that line, O'Grady's team recovered dozens of fragments of tooth enamel from extinct Ice Age species, including an ancient camel and a massive early form of bison. Nearby, in that same deep layer, sat a single hand-shaped stone tool made of orange chalcedony, worked with multiple edges for cutting, scraping, and sawing, the kind of all-purpose tool a person carries and uses for years. When the associated animal remains were dated using two independent methods, both landed in the same startling range, roughly 21,000 to 22,000 years old. That's deep into the last glacial maximum, a period when most of Canada sat under nearly 2 miles of ice, and the so-called ice-free corridor Clovis hunters supposedly used to enter the continent wouldn't exist for another 7,000 years. Someone was already in Oregon, already making tools, already butchering Ice Age animals, long before that corridor ever opened. And these weren't Clovis tools. The style found at Rimrock Draw belongs to what archaeologists call the Western stem tradition. Long, narrow blades with weak shoulders and rounded bases, a completely different tool-making approach from the fluted Clovis point. Different design, different technique, different tradition. And it shows up in the ground thousands of years before any fluted point does. That single detail undermines the entire premise of Clovis first, because you cannot be the first people on a continent if someone else was already there, working stone in a style you've never seen before. Oregon wasn't an isolated anomaly, either. Around the same time these Oregon findings were reshaping the conversation, researchers working at White Sands National Park in New Mexico were uncovering something even harder to argue with: actual footprints. Preserved in the gypsum of an ancient lakebed were more than 60 human footprints, complete with visible toes, arches, and the subtle skid marks of shifting weight. Multiple rounds of dating, first using radiocarbon on seeds, then independently confirmed with conifer pollen, and later with sediment from the surrounding wetland, all converged on the same window, roughly 21,000 to 23,000 years old. Pollen, in particular, draws its carbon directly from living plants rather than groundwater, which closed off one of the most common objections critics raise against ancient dates. Mixed in with the human tracks were footprints from Columbian mammoths and giant ground sloths, evidence of people and megafauna sharing the same muddy shoreline more than 20,000 years ago, at a time when conventional models insisted no humans could have been anywhere near the continent. Then there is the site that pushes furthest into genuinely uncomfortable territory. During a freeway construction project in Southern California, heavy equipment struck bone, halting work and bringing in paleontologists. What they uncovered became known as the Cheruti Mastodon Site, the remains of a single mastodon showing spiral fractures, the kind of break that only occurs in fresh, still-living bone, not in bone that has fossilized and hardened over time. Scattered among the remains were several large stone cobbles that geologists determined could not have been deposited naturally by water. They had been carried in and used as hammerstones and anvils. Uranium-thorium dating, a method well suited to material this old, placed the site at roughly 130,000 years, more than 10 times older than Clovis, predating modern humans' known departure from Africa. The 2017 study published in Nature proposed that some kind of hominin, not necessarily Homo sapiens, was present in North America at that time. It remains one of the most disputed claims in the entire field. Many researchers argue the fractures and stone placement could result from natural processes, even where the original team ruled that out, and the paper is treated with real skepticism by much of the archaeological community. It's worth holding that site differently from the others. Less an established fact and more an open, contested question that nobody has definitively closed. All of this evidence, taken together, forces a bigger question than exactly when people arrived. It raises the question of how. The traditional route assumed everyone walked, crossing Beringia on foot and funneling south through that one narrow ice-free corridor. But if people were already deep in Oregon and New Mexico before that corridor existed, walking cannot be the whole story. Genetic research tracing a maternal DNA lineage called D4H3A back to coastal populations in East Asia suggests a second, earlier route, a slow migration by boat, hugging the Pacific coastline from Northeast Asia down through a corridor of coastal resources, sometimes called the Kelp Highway, reaching the Americas without ever needing an inland ice-free gap. That fits with older evidence from the Mediterranean island of Crete, where stone tools resembling those made by archaic human relatives were found in contexts suggesting open water crossings of at least 40 kilometers, hundreds of thousands of years before anyone thought seafaring was possible. If distant human relatives could cross open water that long ago, a coastal migration along a continuous, resource-rich shoreline becomes far more plausible than it once seemed. Under this framework, the classic Beringia land crossing wasn't the beginning of the story. It may have simply been a second, later wave, arriving after coastal migrants were already established farther south. Step back and look at what a scattering of unglamorous evidence, a coprolite in a cave, a chalcedony tool under volcanic ash, footprints pressed into an ancient lake bed, and a fractured mastodon bone, has done to a theory that stood almost unchallenged for most of a century. Each site pushes the timeline further back than the last, and each one relies on independent dating methods that keep landing in the same range. The number keeps moving. 13,000 years became 16,000, then 21,000, then 23,000, and now there is a site in California claiming 130,000 that the field still doesn't know what to do with. The clean single migration story so many of us learned in school was never the full picture. What the evidence increasingly suggests instead is something messier and more interesting. Multiple waves of people arriving by different routes at different times over a span of tens of thousands of years, leaving traces so faint that it took a groundhog, a construction crew, and a very patient man kneeling in a dry Oregon cave to finally bring them to light.